Well, welcome back to the Azure Podcast. This is episode number 420, being recorded on the 13th of April, 2022, with special guest Sam Cogan. I am Sujit, and on Teams with me, we have Evan, Russell, and of course, our special guest Sam, who we're going to get to in just a minute. But first, let's just talk about all of the news this week. And Russell, I believe you had some items in there, and Evan as well.
Yeah, there was a lot of updates this week, actually, or over the last couple of weeks. But most of them are kind of small technical things or things going GA. But a couple that kind of caught my eye. One was a warning, really. So Azure AD Graph is being retired, and I think the date that was set was June the 30th next year. And the message is really you should be migrating off the Microsoft Graph, which is where all the feature updates are going into now. So they've extended the deadline anyway until the end of December 2022. So that gives you another 6 months to procrastinate and push all your feature updates off. But do get that stuff done because it's obviously important, and then it will be retired and no more going into that. The other one was the general availability of Azure Backup supporting Vault Archive tier for Azure VM. So this is quite important because the Vault Archive tier is a lot cheaper to put a lot more data in. So rather than all the incremental backups, what it will do is put a full backup. So it will cost you more gigabytes in storage initially, but that storage is a lot cheaper overall. So yeah, it's just giving you that option of using Vault Archive instead of Vault Standard. It's rolled out in GA in some selected regions at the moment, and it's being rolled out gradually over the rest of the world as well. One other one that I saw, which kind of feeds into something I saw that Evan put in there about Azure Data Explorer, and it's a new feature which allows support for Azure private endpoints. So you can now connect your ADX cluster through to wherever your data is without using or exposing any public endpoints or exposing data over the public internet. It probably leads on to your point, Evan. You spotted something.
Actually, this solves a real problem for me personally. There's a project I own internally that is heavily dependent on Kusto, and trying to keep source code control with Azure Data Explorer queries and functions is not. There's not a ton of great solutions out there, but now you can deploy your scripting as part of an ARM template for the instance itself. So that now you can sort of, and this plays into the infrastructure as code environment, conversation today, but that really allows you to build that directly in. The other thing I want to loop back around to your comment about the graph, and I don't have the dates in front of me, but there's a whole bunch of classic services that are going to be retired over the next year and a half. Classic web services, classic VMs, all that kind of stuff. So just a reminder to everybody, if you don't have that in your roadmap to migrate all of your classic stuff over into ARM, you need to build it in. We are getting awful. It was always sort of far out there. Yeah, it'll come one day, but it's coming up fast. If you're still using those classic services, you should put that in your roadmap.
Evan, anything else you have for updates?
Yeah, I don't think so. Oh, yeah. Sorry. So we had these are the EB and EBDS VMs. These have a huge increase in remote storage performance. It's basically a new SKU for the VMs, and then also Azure Storage with Azure Active Directory. So Azure Storage tables, excuse me, with Azure Active Directory access. So again, sort of bringing the whole, hey, Azure Active Directory is always your token in. All right, we're trying to get away from using SaaS tokens across the board and move everything to service principals and the like.
Awesome. Normally I get excited to talk about AKS updates, but these days the excitement has moved to Azure Container Apps, which is the new AKS, I suppose. And some of the new updates in preview now for ACA. There's metrics and alert support now for ACA. So you could set up all sorts of alerts and thresholds and whatnot, and based on your log analytic queries. There is health probe support for ACA now, so you can probe your containers for liveliness, etc., and only react once they are ready to go. There's a Visual Studio and VS Code support for ACA now, so you could deploy directly from your
Nice.
code. You can push, a container, your code directly to an ACA container. And I think the most exciting one is that managed identities is now supported in ACA. That was something that was hugely missing before, and I think that'll be. I can see Sam's nodding. I know he's looking forward to that. But yeah, so that's. I want to just make sure that what the funny thing is that they just released the updates at 12 noon EST on this day in the week. So they literally just came online. These updates just became public. I knew about them last night, but I wasn't sure if I could talk about them. And literally 5 minutes ago, they went live on the Azure update site. So I was like, okay, I can talk about ACA now.
Good job cutting that deal. Say, guys, release it right before the show so we can talk. We can be the first.
Okay, great. So that's a good round of updates. And let's turn the mic over to Sam. Sam and myself actually are working on an engagement right now, and that's how I came to know about him. And he's been an MVP, Microsoft MVP for a long time. He's got an amazing blog site as well, which I have referred to often. I didn't realize that, that was the same person. who I was talking to when I met him. So happy to have him on the show to share his insights into all things Azure. But Sam, go ahead and introduce yourself and let us know what you do, the company that you work for, and also what your passion is in Azure.
Yeah, sure. So yeah, thanks for having me. So I'm Sam. I'm a solutions architect for a company called Willis Towers Watson, or actually now WW. We changed the name recently, and I got a shorter email address, which is great. But yeah, so I've been working there for about 11, 12 years now, doing a lot of cloud and Azure related stuff, building out platforms and infrastructure and so on. So I'm an IT pro by trade, not really a developer, but the lines are blurring a lot these days, particularly with things like infrastructure as code. And yeah, I'm an Azure MVP as well. So I've been an MVP for 5 years, I think it is now. So I do quite a lot of community stuff in terms of blogging, as you mentioned, but also conferences and community events and those sort of things. So it's great to be able to sort of work with the community and help other people get up to speed with Azure and learn about all the fantastic cloud things going on.
It's good to have somebody who's speaking the same language as me. I don't have to translate on the fly today, which is really nice.
True.
For those that aren't on the YouTube and listening to this, I'd just like to explain Sam's background. He's got a whole load of really, really nice models. So there's a bit of Star Wars and all sorts of other Lego models, but he's got his MVP trophy and pride of place behind him there.
Then maybe you could just spend maybe a minute explaining what the WTW does, and that'll give us some context in the discussion as we go forward.
Yeah, sure. So WTW is a pretty big company. So I work in a specific bit in the financial services section. So we do a lot of work with building applications for modeling risk. So helping insurance companies sort of model, what's going to happen in the future, how much are they likely to spend in paying out on insurance claims, how much are they going to have to pay for car insurance claims and all that sort of stuff. So we do a lot of predictive modeling, a lot of sort of random number generation and all that sort of stuff. So it's a lot of very complicated maths that I really don't understand, but we build software to do that, and it's the software is fairly complicated, and we do a lot of sort of intensive calculation stuff. So we do quite a bit of large grid compute, very in-depth stuff, which is why the cloud has been a big thing for us over the last few years, because being able to scale up infrastructure to deal with these big batch jobs has been really beneficial. Before you had to buy big sets of infrastructure that potentially would sit idle for half the year. Now we can just get as much infrastructure as we need for doing the job and then turn it off when we're done. So that's one of the reasons why we've really embraced doing cloud services within WW.
So the word infrastructure as code, like you mentioned earlier, has been thrown around for quite a while, and like the definition or the context in which people use it varies quite a bit. Like, sometimes you're writing a little script, infrastructure as code. I'm like, come on, not everything is infrastructure as code, that's a utility script or whatever you want to call it. But, let's set us straight and tell us, what is your view or definition of infrastructure as code? How should how should cloud architects or cloud engineers think about that?
Yeah, so as you say, infrastructure code could, I suppose, be any sort of script or anything you get that deploys infrastructure. But in today's world, we really think about is using infrastructure as code to declare your cloud infrastructure. And really, there's a few tenets that you sort of look at it and think, yes, that's infrastructure as code. So things like using a declarative approach. If you look at any of the major IEC languages, it's all declarative. You're saying what you want, you're not defining how you get it. You're just saying, I want a VM or a storage account or so on. I don't care about how it gets created behind the scenes. I just want that. And that's the kind of the big difference between that and writing a bit of PowerShell or Bash or so on, where you're just writing a do this, do this, do this. That's kind of one of the big differences between them, is just being able to declare what you want. There's also a few other things like, things being idempotent. You nowadays, if you run an infrastructure as code file, you expect that if you run it once or you run it 10 times, you get the same output, and you're not going to break things by running it again. Whereas again, if you go back to your PowerShell script, unless you spent a lot of times adding in if statements, you say, if it exists, do this, if it doesn't, do that, and so on. If you don't do that, then the second time you run it, it's going to behave differently to the first. So idempotency is kind of another really important tenet of infrastructure as code. Those are kind of the biggest things. There's a few other, lots of little bits and pieces, but those are kind of the biggest things that jump out at me, which define, is this infrastructure as code or is this just a script?
And
Go ahead, Sajid.
I was just going to ask follow up, what are some of the, I guess the tools that someone should use for ICO? You have tried and would like to suggest here.
Yeah, so there's quite a few tools around now, and they kind of fall into two camps of the sort of cloud native, not cloud native, but cloud specific tools, and then the more generic tools that go across clouds and other platforms potentially as well. So if we focus on the Azure world, you've got ARM and Bicep, which are the sort of Microsoft tools that are designed specifically to work with Azure. They don't do anything else. They just deploy Azure resources. For those who aren't familiar, ARM or Azure Resource Manager templates were kind of the original Microsoft infrastructure as code tooling, where you wrote that in a JSON format. Recently, over the last couple of years, Microsoft have released a new tool called Bicep, which is built on top of that, which uses a more abstracted language and is perhaps a bit simpler to use and easier to get to grips with. Essentially doing the same thing under the hood, but they are the Microsoft specific ones and they work with Azure. Whereas there are some really big tools like Terraform is probably the most popular one you hear about, which is made by a separate company called HashiCorp, who work across clouds. So you can deploy resources in Azure, in AWS, GCP, and non-cloud things like Kubernetes clusters, GitHub, all sorts of different providers. And allowing you to use the same language across all of those. Another tool, Pulumi, is a similar approach, cross-cloud piece, not quite as big as Terraform, but it is gaining popularity, which is a similar sort of thing across clouds and providers as well. Those are probably the big ones. There's a few other smaller pieces. There's one called Farmer, which is an Azure-specific one, but as an open source project. Yeah, those are the most common ones we hear about.
And I don't necessarily, I suspect there's probably some elements of a religious debate here, but when you were talking about the scripting versus the declarative model, right? When you think about, and I sort of talked about it with the Azure Data Explorer thing, where I'm declaratively defining, hey, I want to create this Azure Data Explorer instance with these tables and this structure, but then I do need to run some scripts to create my tables and the like. Is the fact that I'm doing that mean I'm blurring the lines at that point, or is there just an assumption that for an infrastructure as code level, there's going to be things that you just can't do declaratively because of some very legitimate reason? I shouldn't look at, does that mean that I failed at infrastructure as code if I have to do that point? Or I guess that's what I mean. And it feels like we could get into the religious piece, but like, should I always be looking at, hey, it's a script, figure out a way to remove it. Hey, it's a script. Like, is that the iterative approach I should be looking at?
Yeah, so in my view, I always try and aim not to have scripts in my infrastructure code, but it's not always possible. And I don't think you could say it's failed. I think there are just some things that aren't feasible. back in the early days when we looked at ARM templates, you could deploy a storage account, but you didn't used to be able to deploy a container into a storage account. And so the only way around that was to run a script or some sort afterwards. Now, they've introduced containers in as an ARM template piece. So, things are expanding and changing over that. Some of the third-party pieces like Terraform, obviously with their benefit that they're building sort of an abstraction, they can then layer on things on top of that, which then expose them as infrastructure as code as well. So the storage account one was a good example. Terraform had the ability to add a container before ARM did, but all Terraform was doing under the hood was calling the REST APIs to do that, but they abstracted it. And yeah, so it's not always possible. And a lot of the time I will find that at some point I have to break out of the ARM template and do something like a script. One of the pain points is whether you can do that still as part of the template, or whether you have to then use some sort of extra orchestration tool on top of your template to then run the script. The things like ARM and Bicep now have this deployment script functionality, which lets you run a PowerShell or Azure CLI script as part of your deployment. It basically behind the scenes, it spins up a container instance to run it, but it lets it be part of that workflow rather than you having to orchestrate it. It's still not as nice and it has its downsides, but it means you can still encapsulate that in a single piece. Similarly, like Terraform and Pulumi both have the ability to sort of break out and do a local exec of something as part of the deployment.
DSC and everything would be another scenario where you see that. Okay, so then I think then what I'm hearing is that the key is to be striving for that, and if you can't achieve it all the way, figure out if you can do it away so that it's part of your declarative framework rather than, okay, I declare all these things and then I go off over here and run the script, right? You sort of want to make it part of the whole package. If I'm
try and put it together, but also try and make it at least idempotent as well. That's one of the big things. If you look at the docs for deployment scripts, there's a big warning about this, because every time you run your template, potentially your script's going to get rerun as well. And while the template will take care of the idempotency for you, the script won't. So you need to write that script to at least be aware, again, put some if statements or something in that says, if it already exists, I'm not going to do anything this time, or something like that.
Okay, so be aware, but I haven't failed if I end up still sort of being backed into a corner somewhere. Okay.
No, once you get to the point where you're doing some things more complicated than a network and a VM or something like that, you're gonna end up hitting a point where there's something potentially you can't do just with pure IAC.
Okay.
Sam, when you're talking about idempotency, I'm curious, what are some ways that you'd recommend our listeners to validate these sort of infrastructure as code templates? Because every time, if you want to just do a deployment, it could take a lot of time.
Yeah, and that's a big tricky topic to deal with. So one of the nice things about IAC is that it is code. So potentially you can write tests. You can use testing frameworks to look at your code, and it depends what language you're doing. Some of them are more suited to it than others. For things like ARM and Bicep, where it's not an executable language, then a lot of the time to test things, you've actually got to deploy the resources, which can take up quite a bit of time. Whereas if you look at something like Pulumi, which is it's similar to Terraform, but is written with actual real programming languages, so C# and Go and so on, you can actually write unit tests with that, and you can mock things, and you can do so if similar things that you would do with a standard application. And so some languages are more amenable to testing than others, but you can test pretty much anything. But sometimes the testing will involve you deploying the resources, which takes time, costs money, and so you've got to kind of factor into that. How much effort do you want to put into that, and how much cost to make sure that it's going to meet your needs. There are certain things like ARM and Bicep now have this what if command, which allows you to try and look at what you're going to get before you deploy it. So same with Terraform and Pulumi have a preview approach, and that's a really useful tool for testing, because you can get the data out of that and compare it to what you think you should have got, and see if you can figure out if there are any differences before you do that. Similarly, there's tools like Chekhov, which is a testing framework, a security testing framework, which allows you to validate your what you're deploying against best practice and common infrastructure mistakes. There's the ARM template test toolkit, I think is the right acronym, which allows you to test your ARM and Bicep against sort of best practice in terms of how you've written the scripts. So there's some pretty useful tools you can use there to try and sort of catch things early.
So I think you're talking about the template and the declarative bit, which is all great. But the thing that's kind of in my mind is this phrase about friends don't let friends write, mouse click and publish, right? And that's all about the governance bit and automation and making sure that there's no configuration drift of what you've deployed or produced in your template versus what goes on. How important is that automated deployment piece? And as well, I guess there's a bit about these services that we produce, where we're encouraging citizen developers, and we're encouraging people to use the UIs to build stuff, and they're going straight to a portal and typing stuff in. So you can go to Azure Functions and go and do that. You can go in Power Automate or Logic Apps and go and do that. How do you stop people doing that?
Yeah, it's difficult, and sometimes you don't want to. I mean, you kind of want to give people a playground where they can actually test things out and try things out, but you kind of want to ring fence that and make sure it's in a development environment and it's secure and so on. So you can get to the point where you start using things like Azure policy and those sort of things to actually decide what can be deployed and how it can be configured. So you can write a lot of best practice in Azure policy to say, if you deploy a storage account, it's got to have HTTPS only, it's got to have private endpoints configured, all that sort of stuff. So you can build your policies so that it will guide people to doing the right thing anyway, and even use the ability to actually rectify what they deploy as part of the policy, so it will fix problems for them as well. So that's one area you can go down, is making sure that you've got the right policy and approach in place to sort of guide people down the right path. I guess the other point is, once you get to the point where you're deploying resources, particularly into production, you need a more governed process to do your deployment. Having people write the template and deploy it from their desktop is fine for development when you're still writing the template and trying to figure out how it all works. But as soon as you want to get into that sort of production approach, you want to have a governed process for how changes get into that template, how they actually get deployed. Ideally, you don't want the person who wrote the template actually to be the one who has the permissions to deploy it. You want some approach to do that. And again, we're back now at the fact that this is, again, just code. So you can use pipelines. You can use Azure DevOps or Jenkins or whatever your DevOps tool of choice is to build pipelines that can run the deployment. They can run as a service principal or a managed entity that's got the right permissions that you don't have access to. You can check all of your scripts into source code, so you've got a governance around who made changes, and implement a PR process to govern when changes come in, and even start getting into a fully automated CI/CD where someone checks in a change, goes through a PR, run some tests as part of your PR. If they succeed, it gets approved and automatically rolled out into production. You could go as far as that because it's just running some code.
And sorry, is that are all services covered in Azure for doing that kind of thing? Because we talked about the scripting within Azure Data Explorer earlier on. That's only just come on. Are there other problem areas that you see? And
yeah.
How do you deal with the Power Automate side of things as well, or is that out of
scope? So I'll come on to Power Automate stuff in a minute, but so for most of the Azure services, and nearly all of the Azure services on the control plane level, are covered by ARM. Where it gets a little bit tricky is when you start looking at the data plane, where some things are and some things aren't. Storage account containers are technically data plane, they're covered, but some of the Data Explorer pieces you were talking about there and those sort of things aren't. And that's where you potentially end up looking at scripts and other things to work with the data plane side of things, which can make it a bit tricky. There's also a big separation between Azure and Azure AD. So there, ARM does not cover Azure AD, and so if you want to deploy applications or use those sort of things, then you're looking at scripting or alternative approaches like Terraform, which has an Azure AD library. Power Automate and Power BI again are another separate beast because they're technically fall under Office 365, I think, which is a completely separate piece. So there really isn't an easy way to do things like Power Apps using infrastructure as code. It's even quite difficult just to do code in general for Power Apps and checking into version control and those sort of things. So that's an area where absolutely, if you've got these citizen developers, it's quite difficult to push them down this path because it's not as well formed as plain old infrastructure.
Yeah, just a quick.
I have to say
ahead,
there has been a lot of improvements in that area where now there's the idea of solution, and there are a lot of tooling integration, for instance, with Visual Studio Code. And
with Power Automate?
With Power Apps.
Oh, with Power Apps. Oh, okay.
Yeah.
Okay.
But yeah, really, I think from the
That's cool.
Power App side, they're also trying to integrate a lot of the same concepts that we are used to in terms of source control, in terms of DevOps, in terms of CI/CD. But just wanted to add that there's been a lot of improvements, and obviously there's more to go, but it's been a better experience now.
Oh yeah, it's definitely better than it was.
Just wanted to quickly follow up on the question Cynthia asked earlier about how you validate the code. I've been using the VS Code extension for ARM, for ARM templates, and it's pretty good. It caught a few errors that I had, some incorrect syntax. So it does try its best to help you there. So that's one possible help you can have. But the question I had for Sam is, so if I'm somebody new that's coming into Azure into this DevOps role. What's the best tool? You mentioned a few tools we could use. What would you recommend is the kind of easiest tool for someone to get in to say, okay, at least I have some infrastructure as code, right? As opposed to doing it through the portal and exporting an ARM template from there or whatever. I don't know how you do that.
Yeah, but the easiest place to start today is Bicep. That's no question. I think is the easiest way to get started. I wouldn't recommend anyone picks up ARM templates anymore. Bicep has now got pretty much 100% coverage of what ARM can do, and it's a lot easier to use. So if you're starting fresh, you go down the Bicep path. Things like Terraform and Pulumi and so on are very powerful, and particularly if you need to do more than just Azure, they can be very beneficial, but they have a much steeper learning curve, particularly because of their implementation needing a state file. You've got to deal with how you manage that state file and so on. The state file brings a lot of powerful capabilities, don't get me wrong, but as a beginner, it can be a bit daunting to get up to speed with how that works, how to store the state file securely, how to deal with previews and that sort of stuff.
What is the state file? I'm not familiar with that.
So Pulumi and Terraform have this state file, which is a means it uses to record what it's done. So when you do a deployment with ARM or Bicep, it deploys your resources and then forgets it ever did anything about it. So if you run it again, it will basically just goes and runs it and deploys it and looks at what's actually in Azure and but even makes changes to those. Whereas Terraform and Pulumi know what they did on a previous deployment. And the reason they do that is because then they can do things like the preview command, which allows them to compare what you're asking it to do now to what it did last time without having to go and read all of the resources in Azure and getting all the details directly from those. But also it allows it to do a delete or a destroy, which is quite a powerful thing for cleaning up, particularly when you're doing development. With ARM or Bicep, because it doesn't know what it did after it's done. If you want to delete all the resources you deployed, you essentially have to go in and either delete them manually one by one or delete the resource group that they're in. Whereas with Terraform and Pulumi, you can run a destroy command and it will clean up what you did. And that's quite powerful, particularly if you're doing Azure AD, which is one of the areas I found a big benefit. Was often when you deploy an application, you're also creating a service principal or similar with Azure AD. And when people come and clean up and they delete the resource group, they always forget to go and delete the service principal, and you end up with hundreds of service principals kicking around that have expired keys and nobody remembers what they were for. Whereas if you create that with Terraform or Pulumi, it will clean them up for you as well. So that's the state file has some quite powerful capabilities in terms of that. But you've got to manage that state file. That state file basically contains all the information about the resources you deployed, including secrets, storage keys, or things like that. And so you need to make sure that you're storing them correctly, you're encrypting them properly to make sure they're secure and so on. So it's a lot of extra overhead, but it has its uses.
We've talked a lot about infrastructure as code, and I think you've done a masterful job of clarifying that for us. But I've also heard about configuration, right? Configuration is another item that sometimes gets blurred with infrastructure, or maybe it's not infrastructure. How do you view configuration versus infrastructure?
Yeah, so configuration as code actually potentially has been around or been a thing longer than infrastructure as code. And it's configuration as code in my mind is about how you configure the resources that you deploy with infrastructure as code. And in particular, the primary example of configuration as code is virtual machines, or even actual physical machines as well. And so some of the common toolings in that area are things like Puppet and Chef and Ansible. We've probably heard of most of those. And they're designed to run an agent on a machine, and you configure how the operating system and all the applications that run inside that machine are set up. And so usually there is a line where you use infrastructure as code to deploy the VM, and then you use configuration as code to configure it. And potentially there's a handoff between the two. It's very common to see, particularly in Azure, there's an extension for most of those things. So your infrastructure as code deploys a VM, it installs the Puppet extension onto that VM and passes in some parameters for it potentially, and then Puppet takes over and configures the internals of that VM. PowerShell Desired State is another example of a sort of Microsoft native tool that can do the same sort of thing. Nowadays you do see a bit of blurring of the line between that, whereas where you've got infrastructure as code that can do some configuration level work on the VM. There's tons of extensions you can deploy now for a VM, which will actually configure the OS and install some software, or there's one which will install certificates on the machine, for example, which has traditionally been a configuration as code approach. There is a bit of a blurred line, but even going the other way, you've got Ansible now, which can do Azure resource deployments. It's not necessarily the best tool for the job, but if you're already using it for lots of other things and you want to sort of tack some Azure deployments on the end of it, it can do it. So yeah, it's a bit of a blurred line now, but there are two different camps.
And if you do something like AKS and you use Flux to pull in the rest of the deployment, is that considered configuration then? Is that an example of configuration?
Yeah, so Kubernetes, I think, is the true blurred line of this whole piece. In that, you can deploy a Kubernetes cluster with Terraform. You can also then deploy the resources onto the Kubernetes cluster with Terraform, or you could install the Flux extension and have that pull the resources on it. And so that, infrastructure and configuration in Kubernetes are very much blurred together now, and you can use any of the tools to do most things, I think, now.
Just reflecting on that, when I'm thinking about the things that are really complex to set up and configure, they tend to be more towards the IaaS and the infrastructure side of things. So once you get into the depths of Kubernetes, I know it gets really complicated, but we abstract that out with container app services, or if you're looking at VMs and you go to app services, you've got a lot more. I guess you've got a different level of control that's exposed to ARM that you can control within that control plane, rather than having to go into the thing to try and tweak stuff that's not exposed, I guess. So
yeah, exactly. And ACA is a great example of that compared to Kubernetes. ACA is a purely ARM deployed resource. You are configuring everything that you deploy, including which version of the containers and so on, through the ARM fabric. And so you can basically do the whole thing with an infrastructure as code approach. You're paying for that in the fact that you can do less customization and it's not as complex. But if all you need to do is get a container deployed and run, then that's potentially the simpler approach.
Yeah, less to go wrong, I guess, as well.
Yeah, exactly.
Sam, you mentioned languages like Terraform and Pulumi are more cloud agnostic, meaning that it could be used for Azure, AWS, GCP. What is that experience like? What can be shared across different clouds, and what are specific to individual clouds when you're using something like Terraform?
Yeah, so that's a really important question, because I think when you talk to people about this initially, you kind of get the impression that you could write a piece of infrastructure as code in Terraform and then deploy the same code on AWS or GCP or Azure, and that's not the case. And Azure VM in Terraform is a different bit of code to a GCP VM. Or AWS VM. There is a different object for each one, so you're not getting that kind of reusability at the code level. But what you are getting is you're using a consistent language across all of your clouds. You're using a consistent method of actually running and deploying the resources, and you can integrate them into the same project. So you could absolutely have a Terraform project that deployed an Azure VM and then an AWS VM and got them talking to each other. A really common use for Terraform and Pulumi is Kubernetes. How you want to deploy an AKS cluster, and then you want to deploy some containers onto that AKS cluster. You can do all of that with Terraform or Pulumi in one project. because it can talk to both of those resources. Whereas with Bicep, you can deploy the AKS cluster, but at that point, it doesn't know how to talk to Kubernetes, so it can't go any further than that. Now, there are ways around that, using things like extensions on Kubernetes to install things like Flux, and then have that pull the resources in and so on. So it's not a hard stop at that point. But with the third-party languages, you can they know how to talk to both.
It sounds like as I listen to you and I go back to what we were talking about earlier, this is still evolving. It's different. Like you said, different clouds have sort of different implementations even within the common tools, but it's really about the mindset. And you may accomplish it a little bit differently for GCP or for AWS for the same thing, or an IaaS VM versus an app service, but you're sort of shooting for the goal of, hey, I want everything to be declarative and idempotent. Now, how I do it, which tool I use, all that sort of flexible and variable depending on, what it is you're actually going to do, for your specific project. But it's sort of where you're shooting for that North Star, really, if you would.
Yeah, absolutely. Yeah. So when you're writing these things, the language may be different, but you're writing it in a very similar way. You're declaring the resources. You're running through a process. You're looking at dependencies and all that sort of stuff. And it's the approach is very similar. The language is different, and how you use those resources. how you do loops and conditionals and all those sort of things that are different and are nicer in some languages than others. But the actual how you're thinking about it is very similar.
Great.
Awesome. Well, Sam, this has been very enlightening. Thank you very much for sharing all your insights into infrastructure and deployments. Appreciate that. And any last question for Sam before we let him go?
No, this is great.
I was going to make a joke about Halloumi, but it was too cheesy. So sorry. I've not actually heard of Halloumi before. Is it comparable with Terraform? Is it going for that kind of space?
Yeah, exactly. So it's very similar in terms of the fact that it can do multiple clouds and other such things, and a provider-based approach. Its main selling point over Terraform is that you can write in actual real programming languages. So the stuff I write tends to be in C#, which means you can use real language paradigms like for loops and if statements and all that sort of stuff in your code. Whereas I don't know if you've ever tried to do a for loop in Terraform, but it's not very nice.
They're not pretty. They're not pretty in ARM templates either. I've experienced that there as well.
The big benefit with what we found with using Halloumi is if you're trying to get developers on board with taking ownership of the infrastructure. If they already know their language, they don't want to go and learn another language. They want to build it as part of their existing projects. If you're going down a DevOps approach and you want the developers taking ownership, having a real programming language that they know is a real benefit.
All right. Thank you.
I certainly recommend everyone take a look at Sam's blog. He talks a lot about these topics, samcogan.com. We'll put a link to that in the show notes. And Sam, if you have any other links you want to share that you find, in your favorites list that you feel others could benefit, please send them over to me and we'll add them with the show notes.
Absolutely.
Sam,
Thank you.
on.
Thank you.
Yeah, thanks for having me.
Thank you.